Thanks for the intro. I appreciate everyone being here tonight. I'm actually really excited about this topic. It ties together a lot of things and integrates different services together, which I really enjoy. So I'm excited to do this presentation, and I hope you enjoy it. The objectives that we're going to cover are several. The first thing I'm just going to level set and talk about the various copilots that Microsoft provides on their stack. I assume everyone that's here at a Microsoft focused user group, you're kind of interested in Microsoft's copilots. But we're actually going to think about how we can build our own copilots to service our own workloads and our own data and our own applications. But I'm going to start there with what Microsoft has and what tooling they have that we can take advantage of to both leverage the first-party platforms as well as use Microsoft tooling to build our own things. So as we build this Copilot, we're going to start with data that we're going to put into OneLake through Fabric. And then Fabric has some data science capabilities and AI capabilities, and we'll actually use those tools to enrich that data so we can provide an even more interesting chatbot or Copilot experience to users. So we'll do that within Fabric. And then from there, we'll actually use AI services to take the data that we prep and enrich in Fabric and put that back into an AI search engine within Azure, and then finally use the search engine to build a Copilot using a tool called prompflow, which you may be familiar with or not, but you'll know all about it after we go through it. And then we'll deploy that to an application. So it's very broad. We'll deploy the application. So this is so it's going to be kind of broad. I'm not going to code live, but I'm going to walk through all the code and the different tools that we're going to use. Make sure you understand them. And if you have questions, we can stop and go through things in a little more detail. So just let me know. So just kind of level set, what's a Copilot? Copilot is really Microsoft's term for, we've had chatbots for a long time. I've been, in this industry for a long time. I think the first chatbot I used was Eliza on a Commodore 64, and it was kind of cool, but it was nothing like what we can do today. And the way Microsoft defines a Copilot is, kind of a conversational application, so a chatbot, that's is built with traditional tools, but almost invariably will use generative AI or large language models to go beyond what we've been able to do in the past with simple chatbots, and actually have chatbots that understand what we're asking in natural language and can deliver results in natural language as well. And not just language, but also videos. So this is Microsoft's Copilot within their browser, and I said, show me pictures of a green bench. It knew what I meant. It was able to find the results, and it was able to kind of speak back the result in natural language for me. So that's what they mean by Copilot. I think it's a pretty good definition, and certainly it's kind of a user interface paradigm that we probably haven't been able to use before so much, before some of the generative AI and LLMs that are available publicly, that we can integrate in applications pretty easily today. So just to kind of like Microsoft's Copilots, again, just level set with that. So really they have three categories. They mean Microsoft that they have developed and have put into the field. So it's kind of embedded, solution accelerators, and custom. So embedded accelerators are kind of the ones if you use Copilot for Microsoft 365. A lot of that experience is embedded. You're using the Copilot to enhance to have an enhanced experience for a product. But that Copilot or chatbot is pretty much locked up in that product. You can't use it generally with other things. So GitHub Copilot, you use it to write code. You can't really use it to search for what's playing at the movie theater down the street. So it's pretty much locked into that application embedded. Makes a great experience, but not really general purpose. The second category that that Microsoft delivers are kind of solution accelerators, is a term for that. So generally, there's low code. There are some low code tools there that it can be extended. So Microsoft Dynamics has some capabilities here where you can create your own chatbot that connects to Salesforce or to other data sources. So here you can start to to build custom applications or customizable chatbots, but they're still, kind of limited to the channel. So they're not completely free form. You can't do anything you want, but they do extend and provide more experiences for users that they wouldn't otherwise have from the product out of the box. And then the third category is custom. So this is the one I'm going to focus on in tonight's presentation. And it's, we have our data, we have an idea of what we want to do with it. It's not connected to an existing product per se. It's just something we want to deliver to our users. And that's more of a custom Copilot or custom chatbot that we're going to develop. So I'll kind of highlight that. And in the Microsoft tooling, which I'm going to focus on, and you don't have to use Microsoft's tooling at all, but I'm going to go ahead and use the different tools Microsoft has and kind of thread them together into a solution. And the two main solutions that Microsoft provides for us to use are Copilot Studio and prompflow. And just to talk about the difference between those, Copilot Studio is more of a low-code environment. prompflow is more of a custom code environment. And I kind of give you a sense of what that looks like. So in a Copilot Studio solution, you can see it's more of like a visual drag and drop, connect the dots, pass parameters between. You can do some coding or some customization, but mainly Copilot Studio is about connectors that you can use to connect into your solution and drag and drop and flow things through. So you can do some pretty compelling Copilots that have generative AI behind them with basically no coding at all. But you might want to go beyond that. And to go beyond that, the Microsoft has another platform within Azure machine learning called prompflow. And prompflow it's kind of like Copilot Studio, except it's quite code based. So the advantage of that is you can do literally anything you want. Instead of, if I go back a slide, instead of these predefined boxes that are pretty scripted as to what they can do. So, these conditions, this is an if statement, but it's in a dialog box, and the different things you can do are pretty prescripted, but it's very cool. You can put things together very quickly. prompflow takes kind of the other approach where you can do literally anything you want. So if you can write it in Python, and in this case, what's on the screen is, calling a web service in Python code and then passing that through the user experience. So you can do kind of anything you want. And this is the tool that I'm going to use to finally build our chatbot tonight, because it kind of lends itself pretty well to the external application that we're going to build. And then just to summarize that, between Copilot Studio and prompflow, Copilot is a very visual flow, and prompflow is a visual flow as well, but you could kind of see the boxes along the flow were, not dialog boxes, but more code blocks that you could put together. And then the logic development, drag and drop versus a little more code based. The UI is a big difference between these two, because Copilot Studio generates the UI for you, and then you can embed it into applications, which is really good because it generated the UI. prompflow really provides a backend that you can put your UI around. So that can be an advantage if you want to embed it into an existing application with your own UI, and so on. So and then channels are a big difference between these as well. Copilot Studio has kind of predefined channels. In other words, where the experience can be, or where the Copilot can be experienced by users. And there are a lot of channels with Copilot, and it's growing, but Teams, Facebook, websites, you can kind of embed the HTML into your website. And the channel supported by prompflow is pretty much open. If you wanted to have a prompflow Copilot that you embedded within a native Android application, you absolutely could do that. So there are really no limitations. And then on the pricing model and how things are distributed, Copilot Studio is really like they charge per user session. So it's almost completely a SaaS product. You don't have to manage anything. You just pay for, as it's being used. And prompflow is really deployed as kind of like an Azure endpoint. So you're kind of paying for the compute. You decide how much compute you want, how many nodes are in a cluster, and then you pay according to how much of those resources are actually consumed. So it's a little bit different in that sense.
So Rob, I'm
Yep.
monitoring the comments in the chat, and for everyone attending, feel free to pose your questions there, or you can come off mic and speak up if desired. But Harry is asking,
Yeah.
is it
I'm
easy
reading that.
to integrate promptflow into things like Streamlit or web front ends?
It's a really good question. So the demo I'm going to do tonight is Streamlit. So yes, on that one. But yeah,
Okay.
promptflow essentially when what you deploy is a web service endpoint. So it's a REST endpoint, and you can anything that can call it with REST, you can call it. If you want to use Streamlit, which is what I'll use because it's a pretty easy thing to put together really quickly. You can do that. You can use curl at the command line on a Mac. That would work. Not many people would do that. But yeah, promptflow is really the back end of whatever application you want to bring to it. And oops, I've got some overlapping. Oh, does promptflow have run on Azure? Or can it be service set up outside of Azure? It does run on Azure. So it's part of the Azure machine learning. You deploy the endpoint, which we'll do, and that becomes runs in the Azure PaaS environment. But good question. Okay, so we're actually going to go ahead and build this, and so what we're going to do tonight is actually well, I've already built it, but I'm going to walk through how it's fun. But this is the solution is using some source data as really images. So what we're going to do is actually our source data is going to be images that are available from New York Met. So they make their catalog of a whole lot of public domain images available, and we can incorporate that into an application. The application we're going to build is going to let users ask to see works of art that are in the catalog, but rather than just on the predefined metadata, what we really want them to do is to say what they want to see. So maybe they want to see a bowl or a chair or a table or something that's made of glass or metal. That's not provided by the Met's data source. But we could get it out of the image if we could have a way to analyze the image. So we're going to use Azure AI to analyze these images after we pull them into Fabric. And then we can store all of that in Fabric and then write it out into a searchable index and then use promptflow to let users talk to their to a Copilot to say, hey, show me, in this case, show me a green bowl, and we can see a green bowl, or show me a chair and we can see a chair. And I didn't take this too far in terms of making it a production great application for the Met, but just enough so we can see how it works. But that's what our end result is going to be. And the source data, I will show you in a minute, but the source data, what is actually available to us is a little bit of keywords, the image URL, maybe which department it's in, but like this text you see on the screen where it says this image shows a green bowl on the table, etc., completely generated by OpenAI GPT. So that this is our generative AI piece that we generated, as well as just the keywords and so on. So you'll see that. But the basic idea is we're going to grab these images, we're going to pump them through some AI models to analyze them, give us some enhanced metadata that Met didn't provide, and then use that to let users query in natural language and then describe to them what it is that we found for them. Architecture-wise, because I like architecture diagrams, I hope you can read it. But just a quick flow of, we're gonna hit a bunch of little steps here. But I wanted to give a 30,000 foot overview of what this is going to actually look like. So you can see in the up here on the top left, we've got kind of the Met. So we have this New York Met open data source. I'm going to use a subset of it. It like has a couple dozen works of art in it. It's not really important that we got the whole thing into the demo, but I brought in enough where we could play around with it. But I'm not bringing in the entire thing. And then we'll use Fabric to pull that out. It's the subset that I'm going to pull is stored in an Azure Blob Store. So I'll pull that into our workspace within Fabric. And then while it's in the workspace, we'll run it through Azure AI to analyze the image. That will give us some more tags, some descriptions, some the size of the image, but I'll show you what we'll get out of that. But we don't have to do this manually. We can use some AI models to help us with that. And then once we've enhanced it, so we'll have, instead of 10 columns of information, now we'll have 20. We're going to put that into an Azure AI index. which is a really good approach if we're going to have a lot of users querying the data. We don't necessarily want them querying a data lake for that. But an AI index is perfect because it has millisecond response time, and it can very flexibly index everything for us. So we'll push that out. Now it kind of is important that as we let's say the METS libraries and catalog is getting enhanced, all we would have to do is schedule our notebook to run or have an integration job run and just continually update the index, and the end user application will be updated as well. So we're using we're using really Fabric for our data management, and then like a website for the user experience. And then on the right-hand side is the prompflow development. So we'll kind of step through this, but on the prompflow side is where we're really going to use OpenAI. So we'll use OpenAI to, we'll query the AI search index. We'll get information that matches the prompt that the user's giving us, and then we will use OpenAI to sort of format the results so they get that nice textual description of exactly what it is they're looking at. And I kind of, call that out, where retrieval augmented generation is essentially the model we're following. So we're using some database or data source or query source to get the stuff that we want to show the users, and then we give that to the OpenAI model so it can summarize that into something that makes sense for them. And then we'll display that in a web app, which will actually be streamlit. So. And then since this is like a multi-step process, I just put together kind of a little map of, this is what this is the process we're going to be following. We'll just do a step at a time. I think it'll make sense. There's a lot of pieces, but it's a logical flow. So we'll, number one, we'll import the data. Number two, we'll enrich that. We'll use AI models for that within Fabric. So the little F symbol there, the little Fabric symbol, kind of tells you we're going to be in Fabric when we do that. We'll add that into the search engine. We'll do that from Fabric as well. And then we'll kind of switch over and use prompflow to develop our chatbot experience or our Copilot experience. We'll deploy that to the Azure endpoint. That's will actually be deployed to a Kubernetes cluster, and then we'll build the web app on top of that. So the web app, the web app talks to the endpoint. The endpoint will talk to the search index, and Fabric on the other side is updating the search index as the data changes. So we'll be jumping into it. Does anyone have any questions or anything on this content that we should talk about before we move on? Okay. Let me unshare this. Stop. And I'm just going to share my screen because I'm going to be switching between windows quite a bit. So let me do it that way. And let us start. Here, let me go find the right window. There we go. All right. So actually, okay, so I'm in Fabric. So if you're not familiar with Fabric, I assume most people are at this point, but the Fabric environment, when you land, it shows you different experiences. There are different workloads. These workloads, it doesn't mean you can't do everything. You can, but they just tend to customize the landing page for workload. What I've done is created already the notebook that we're going to need. So a notebook is almost kind of like a sequential set of operations. So each cell does one little piece of the process. And in this notebook, I just have some headings here to say what all these little pieces do. And each of these cells, in my case, are in Python, but they don't have to be. So if you would rather use a different language like Spark SQL or R or Scala, you can do that. So I'm using Python because it's the easiest thing for some of these things to do. So there are some imports up here, not really that important, but you can see some of the tools that we're going to be using. So this Trident token library, this is an access to Azure Key Vault. So we do need a couple of access keys to access our AI models, and then I've stored those in Key Vault. And then Synapse ML is the part of the data science workload within Fabric. So that gives us access to a lot of machine learning models, but it also gives us some wrappers around the ability to call various AI and ML services in other parts of Azure, and we'll use that today. And then PySpark is essentially lets us access the data lake. So on the left-hand side, you can see our data lake has some files, some S3 files are linked over here. And most of these aren't related to the solution, but you can kind of see we'll put some data there as we go through it. So the first cell here, we're going to fetch our keys from Azure or from Azure Key Vault. Of course, we could just hard code our secret keys into the notebook, but we might get fired if we do that. So we don't do that. And we do store our keys in Key Vault. So the user that uses the notebook actually can't see what the keys are. So if I were to print out this key, it would actually just say it's redacted. I printed out how long the keys are just to reassure myself that I did get keys. But after I get my keys, then I want to get my data. So here's I'm calling this function. So Spark read format CSV. So I want a CSV file, and this is my source. So the Meta Artwork sample CSV, Microsoft conveniently has this in their big library of sample data that we can use. So I went ahead and used that. So if anyone wants to play around with it themselves, you can do the exact same thing. You just pull this data in. You don't have to go all the way to the API to fetch that data. And after we fetch the data, though, we first kind of look at what we got. So with the actual API, because you might be interested in what that actually looks like. Let's see. I think I have. This is the actual API that was used to pull the data into the blob store. But if we look at the data that the Met provides, they show you what calls you can make and so on. And if you make a call, if I'm out here, let me just go into, let me just go in Postman. That's easier. So in Postman, I can call this and I'm going to get the data for one of these objects, and I can see what we get just from the Met. So we get a department, an object name, culture, dimensions, what medium it was used, a credit line. So you get a little bit of information, but I really want to be able to let users search on like what color was it, or was it wood or not, and so on. And they've got a little bit of that, but not everything, and they don't have really a description of what the user's looking at, which is what we want. So that's why we want to update this information, but we don't want to pay people to go through and do it manually. So that's why we'll use the AI model to do it. And here we can see the same data that we have from the JSON response. So there's some information here, but it's not everything we're really looking for. But we will go ahead and write that data into a data lake. So this is how we would save this as a table in our data lake. And if I I already did this, but it's imported artwork. So if I look over here, I can find, here's that table that's been written, imported artwork. And those are those columns that we have above. So we can continue to use that information within the data lake, or add it to our data warehouse, or put it in Power BI. We can do all those things. But for our application, we want to actually enhance that. So here we're going to use Azure AI and basically what we're going to do is analyze the content of each downloaded image. So this is actually a really cool thing I really like about Fabric, is that it has the idea of these transformers. So essentially what the transformer does is we can give the transformer a data frame like this that has all these rows. And what the transformer will do is it will, for each row, actually it does it in the batch, but kind of think of it, for each row, it will ask the AI model to analyze the image and given this URL. So Azure AI model will go and fetch the image. It'll look at the image, it will kind of analyze it, and it will output various things. And we tell it kind of what we want. So we want to have some categories. We'd like it to give us a description, tell us if there are any faces, tell us if it's adult content or not, tell us what color it finds in the image. So this is what the AI model is going to do for us. And then here we just go ahead and run the transformer. So this is like the pattern, or the formula. So here's our recipe. This is what we want you to do for us. And here we say, take our data, which is this data set, and we're telling it, take that data set, do all these things that we just defined up here, and return that as a second data set. So what I find super impressive is, look how many lines of code. That's like 2 function calls. It's maybe 12 lines of code. So we can do so much with just doing that much within Fabric, which is, I think, I find it super cool because I've done this with actual code. It's much more involved. So this is really cool. And if we look at, so we'll say display that DF2. So here we're taking data, doing these things to it, and then assigning it to a new data frame called DF2. And if I look at that DF2, I can see that up until, what was the last column up above again? So this has been appended, and search action upload, that was the last column up above. And if I look here, here's upload. So everything to the right is what the AI model has assigned for us. So it's gone through and assigned it some new categories, and it says, well, I've got about a 58% chance that this is an abstract non-photo. It thinks it's not an adult, it's not adult, it's not racy, which I hope not, because it's in an art collection. Well, I suppose art collections might be, but these are pretty tame. It's actually added its own tags. So these are tags that Azure AI saw when it looked at it, and metadata. So it's telling us how big the image was that it analyzed, what colors it found within the image, which is kind of cool. So that would give us a way to let users say, show me the blue things or the red things, which isn't what we got from the Met in the first place. Is it clip art or not? And any brands. So you can ask Azure AI to, if it identifies like McDonald's or Ford Motor Company and so on, it will list those in there. We didn't ask for that, so we got null. And then any other objects that it found, which we didn't ask for, so we got null. So all this new enhanced data is kind of what we want. And we're going to let people search for that stuff within our final solution. So if we kind of look at where we are, we're getting to the end of step. Where are we? Let me find my model, right? So we imported the data and we just enriched it with Fabric. And now step 3, we have this enriched data set. We want to add that into the Azure AI search, which is what we'll use to feed it into our LLM queries. So let's go ahead and do that. That again is because ML Services has routines for that as well, and it's very, very similar. So in this case, we take DF2, which is this table of information here, and we just, there's actually a function call for this. So it's write to AI search, and we say, you know, what's the key? This is the key I got out of the key vault. What's the action column? Search action. Service name, the service, that's just the name of the service, the name of the index, and then what's the key column. So object ID, every object in the search needs to have a unique key, so we give it a key. And again, this is going to take that whole set, write it out to Azure Search in one go, and then we can use it from there. And then just to make sure that it actually worked, this last cell in this workbook is I'm going to query that index. So Azure AI search indexes are read and written through REST APIs, and you can do it interactively. So I'm just going to bring over, like, if you're not familiar with Azure AI search, it's an Azure service. So here's my search. This is the index that I just updated. It's called test, but not very original. This sample data set only has 25 documents. But if I go into that index that was written from Fabric, I can search for things. So I could say, maybe I want a chair. And you see that's a very quick response time. So that's why it's a really good service to use to front-end public apps. But here I have a search score of 4.32. It's American Decorative Arts. The medium is mahogany. So this was from the Met. And a lot of this other information, like abstract, shape, others, outdoor, the adult, remember that we got that from Azure AI search. These are the tags that Azure AI found for us. It created a new text, a close-up of a chair. So it created that text for us within Azure AI when we ran that through the transformer. It's found, these are the colors in the foreground and background. So that's probably a black and white picture. And then these are additional items. We can also query the.
So Rob, sorry to cut in. So
no, please.
Bruce is asking, where is the location on the AI search index?
Yeah, so search index is in Azure. So if I look at my Azure account and look at my resources, then the search engine index is going to be in here. So when I originally created it, I created it with Azure AI search. And if I wanted to create a new index, I would just do that this way, just like anything else in Azure. This used to be called cognitive search. It was renamed Azure AI search when they last year. But the idea is I'm creating the AI search in Azure. I'm going to use that in my application, but I can very easily update that index from Fabric.
My assumption was that you were loading AI search index in your data lake, but I didn't see it in the code. So where does the index exist?
Yeah, let me go back to that and I'll show you that again. Okay, so let's see, where were we? So here's where we created the new columns. So we have this larger data set. And then this cell is actually where we updated the search index. So DF2 is this table here. So it's 25 columns. And we're calling a function of SynapseML to tell it, hey, take my table, write that into my Azure search. And then these input parameters, it tells us what's the search service. So that search service is called test, or the index is called test. The service is up here. So yeah, so it's in the East region. It's called RHK Search Demo, and the index is test. And then if I look at my Azure portal, I go back to that search index, that'll actually be the same. So here's test, and it has those items. Let me go back. Yeah, so RHK Search Demo. So this is my search instance, and this is the index, and that's what I specified when I wrote it out from here as well. So examine, yeah. So this cell is the one you're looking for. It's and this is SynapseML has a function to do this. So it's kind of like all the complexity is wrapped up in this function.
But index is stored in data lake, is it correct?
The index is actually a service in Azure. So the index is not in the data lake. So we're using the data lake to pull the data together and process it. And then we're taking our results and pushing that into the index. So that'll be stored in an Azure region within the Azure AI Search's data storage.
Thank you.
Yep. Good question, though. That's why that's the risk of this presentation, because it like ties a lot of things together. So I want to make sure it's clear where things are coming and going. And here's where we're going to query that index. So we're actually, we're reaching outside of Fabric to query the index and then looking at what our response is. So in this case, I'm querying this index that's in search service, RHK demo service or something, and then search index is test. This is the query. It's in a Lucene syntax. So we just say, hey, the search is for anything that has glass. And then down here we can see this is what it's returned for us. And here was the medium was lacy pressed glass, so it got that right. So that's good. And then there would be additional content down there. And this is just a smoke test. We're not actually going to use this to demo to create the application. We'll do that within prompflow essentially. Okay, so we're getting ready to move on. So we've imported the data, we enriched it, we put it into that search index. We used Fabric to put it into the Azure search index, but the index is a separate service that's over in the Azure side. And now we're going to use it. So we're going to start developing our Copilot, and we'll use prompflow for that. And what prompflow is going to do is it's going to take the input from the user. It's going to hit the index to get the documents that match, and then provide those to whatever application's calling it. And that'll be actually a Streamlit app, but basically it's a web app that we designed from scratch. So let's look at prompflow. Any other questions before we move on? Okay, let me find the right window. Okay, here we go. Okay, so prompflow, you see up the top here, it says Azure AI Machine Learning Studio. relatively new product from Microsoft. They introduced this. This was in preview through a lot of 2023. Was put into production fourth quarter-ish of 2023, and is a part of the Azure Machine Learning Service. And the Azure AI services and machine learning services are starting to kind of overlap and join together. So I think that's why they co-brand it like this. But what we're using prompflow for is to build the process of our Copilot. Okay, so this is its UI. It's kind of neat. You can do this in this web UI. You can also do this in Visual Studio if you prefer that environment. I'm doing it in the web browser. I think it's a little bit easier to follow along. But the cool thing about this is as we build the flow, it creates a flow chart that we can actually see how it works. So essentially what we're going to do is we're going to take an input. That input will be whatever the user asks for. So maybe they'll say, show me a table, or show me something made of glass, or something like that. So that's their input. And then what we're going to do is we're going to extract keywords from that input. So we're actually going to use a service to do that. So we'll pull keywords out of that. So so we can try to match the content that's in our search index. Then we'll send that query to the search index, which is the Azure AI search. And once that information comes back from the search index,